Hello. Constant velocity model representations. So if an object is moving at a constant velocity, we can represent that with graphs, with diagrams, with words, with calculations and equations, all those sorts of things. So the assignment that we're working on today, we have these whited out sections that are blank, that are not that are blank. They're not necessarily blank, but they're parts that we have to complete ourselves. The grayed out sections have relevant and helpful information, but there's no work for us to finish on those. So this example or this video is going to go through and take a look at um, the last section uh, mentioned here, assumptions or things that must be true for our diagrams and calculations. So as we're going through and we're doing these constant velocity model representations, um, again, the things that we can represent constant velocity with words, with a graph, with a diagram, with calculations and equations. But there are some things that must be true for these to hold accurate, or for these methods to work and be accurate. Um, so some of those things, or one way to talk about it, is, I suppose we should just say flat out, the velocity must be constant. That's just that. And what that means in a variety of ways is that the um, direction must be constant, and the speed, or um, or the how fast part, must be constant. Remember, velocity is both how fast and the direction that we've got. When we have a slope of a line, positive tells us the direction, positive or negative tells us the direction according to our coordinate system, and the number tells us how fast. So that's just flat out saying the velocity must be constant. Other ways to think about it, our position versus time graph must be a straight line. That's Those things must be true for the velocity to be constant. Our position time graph is a straight line. Uh, the velocity must be constant. We can continue to use these different calculation methods in these instances. Another way of saying that the velocity must be constant, or the position versus time graph must be in a straight line, we can say that the uh, position must be um, proportional, proportional to the change in time. Actually, I should probably not just say position, I should say the change in position. So um, these are all different ways of saying, hey, the velocity must be constant for these calculations, for these graphs, for these different methods to be functional and workable. Now, sometimes something might not be exactly constant velocity, but it might be kind of close enough for us to say, this model isn't perfect, but it's close enough for what we're doing. Um, so in some cases, we do kind of accept that there are little bits of wiggle room. But now, if this line has a significant change, well, then it doesn't work. Um, we'll address other spots later on. We'll address things that are not constant velocity and how that's obvious in what we're doing. That's that for that. Good luck. Have a good